Hi, I'm Bob Vila. Welcome home again. You know, we've got a big technology show planned today. We're bringing this house into its second century, and that means all new mechanical systems. We'll get started today looking at our heating equipment, which is a System 2000 boiler, air handlers, and all sorts of interesting bells and whistles, including some radiant flooring. Then we're going to be looking at the electrical systems, including how to pull the wires into the different sub-panels, and we do have an electrical inspection, so that's a very important part of the job. Stick around. It's good to have you home again.
Bob Vila's home again.
We're going to get started today in the basement, and most basements in old New England houses are dark, dank places that go bump in the night because of the furnace and all the other equipment. We've made a lot of changes here. We've got a new concrete floor, we've got metal stud partitions, we've created an area for an exercise room, a woodworking shop, a laundry room, all sorts of specialized areas. This is going to be living space, but there will be a furnace room, and right now let's join Mike Kaufman, who's from Energy Kinetics in Clinton, New Jersey.
Morning, Bob.
Inventors and makers of the System 2000. How are you?
Very good, thanks.
What do you think? This is a pretty impressive installation we've got here.
Frank has done a great job.
We've got a great plumber. But let's talk about the yellow box in front of us and all these components, because I don't really understand how it works. I know that there's gas coming to it, natural gas, and that this system is providing all the heat and all the domestic hot water that we'll need here, right?
That's correct, Bob. What you have is a low mass boiler with low water content, 4 gallons of water, 190 pounds in mass.
Okay, let's review that a minute. What does low mass mean?
Low mass would be the amount of metal to be heated up that's actually what makes up the boiler itself.
Okay, so it's not like those old boilers that had the huge cast iron lamb chops or whatever,
That's
right?
correct.
Okay.
That's correct.
And then the other thing you said was 4 gallons?
4 gallons of water is the total content of water inside the EK2. This is our larger boiler, and we make a smaller boiler with 2.5 gallons of water.
All right. And then what are some of these components? What's this thing here, for example?
This is your external plate exchanger that makes your domestic hot water. What you'd have is the hot water would come up through a pump away on the circulator on the supply side with a bypass line going down through the plate exchanger, which is every other plate is domestic water and every other plate is boiler water. The two never touch.
This is my hot water heater for the whole house.
That is correct.
It fits in the palm of my hand.
That's
How can that possibly work?
what you've got is your maximum thermal transfer between the plates. Your boiler water is going through and your domestic water is coming in cold and every other plate is heating up. Your thermal transfer between the two is allowing for, if it's 50-degree water temperature in, it could be 150-degree water temperature out. You'd have a 100-degree rise going off and being stored into the top of the two 120-gallon storage tanks you have here for your domestic needs.
Okay, at an incredibly fast rate, right?
This will supply at 200,000 BTUs in. It's going to give you 4 gallons a minute or 240 gallons an hour recovery.
And is it still efficient in summer when we no longer need the hot water for heating the house?
Making hot water is extremely expensive. This is about the lowest cost that we're aware of right now in making domestic hot water.
Okay, and because of the storage tank systems, we're not holding on to hot water at all times. We're only making it on demand, right?
That's correct. This boiler will stay cold until it's called for demand. Whether the demand being in this house, you have an assortment of demands. It's a versatile house where you have radiant, domestic, space heating, and so on. When this gets called, it will then heat up and turn around and start immediately without condensing. It's a non-condensing unit. Will recover your hot water and store it between a balance of recovery and storage.
Now, something this complicated has to have a computer attached to it somewhere, right?
This is the system manager, the actual brain, if you will, that actually controls every demand that comes in from the house. And this literally tells the system what to do next and how to distribute the heat.
So this basically acts in conjunction with all of the piping and all the different zone valves?
That is correct.
What do you think of this installation?
This is one of the finest divisions of breaking the zone valves down to be able to balance a house out of this size or any size.
Let's get Frank Idarolo over here, because he's really the man responsible for installing all this copper in here. Frank, nice job. Can you tell us exactly what you got going here?
Well, what we've done here, Bob, is taken each individual zone and isolated it with each one of these valves that you see here. One in the return and another one on the supply, which is right here, so that Basically, we have ease of servicing. If you have a problem down the road in one of the circuits or one of the zones, you can isolate it without shutting down the whole system.
Now, I've got a third floor that's basically a teenager's suite, and if they're gone away to school, do I come down here and shut down some of those zones?
No, that's done automatically with your setback thermostats.
Okay.
We have setback thermostats in each one of the zones that will control the amount of heat when and if you need it.
Okay.
In the
and
zone.
although we're talking gas as a fuel source and we're talking copper pipes filled with hot water, in fact, we're delivering heating to the different rooms in the house via forced air, right?
That's correct.
So what we've got to look at now is what you call an air handler?
Yes.
All right. Mike, thanks. We're going to go on to the
Thank you,
next
Bob.
step for a minute. Okay, Frank, so what's happening here?
Well, John is assembling the return air plenum for this hydro air unit. This is the unit that's dedicated for the first floor heating and air conditioning.
Okay, so the plenum is where the air collects before being either heated or cooled, right?
That's correct. All the air from the rooms is being brought back through this plenum, connected to ductwork, brought up through the unit, which is moved with a blower, goes through a hot water coil that's being fed from the boiler that we just left
Now,
in the boiler room.
this is supposed to be vertical, though, isn't it?
That's correct.
Is it ready to go up?
It's
is
ready
it very
to go.
heavy?
It's very heavy. I better get back there.
All right.
Okay.
Oh, it is heavy, yeah.
Okay.
And it just sits on the slab like
Looks
that,
like
right?
about it. Now we have a canvas connector here which eliminates any vibration, noises, or anything. It's a rubberized connector.
So
We
that's
do
a
this-
transition between the ductwork and the...
That's correct. That kills all the noise, all the sound.
Excellent. And then the copper pipes will be joined to here. But can we take a look inside here to see?
Of course.
Half a dozen screws. Okay, well, why don't we take a break for some messages while we remove this panel? Don't go away. Okay, we're back and we're getting ready to solder some copper pipes together that connect with the boiler, right, Frank?
That's correct.
So this will bring the hot water over here via these pipes. And what is it you have to do before you can solder the copper pipes together?
What you have to do is clean the copper tubing with an abrasive cloth
Yeah.
to remove any impurities. Then you flux it with a brush. And what that does is breaks the surface tension of the metals so that the solder will adhere to it.
Yeah.
And then you heat it up to a temperature of 800 or 900 degrees for the type of solder that we're using. That will fuse the joints. Now this is the hot water coil that connects back to the boiler that we just left. And the boiler will have a zone valve that will open on demand from the thermostat from the ground floor level, which is what this hydro air handler handles.
Okay.
It will open a zone valve, pump the water through the piping into the coil. The blower will be running, and it will take the air and blow it past the coil, temper the air, and blow it to all the rooms.
And that's essentially how you get hot air from this particular air handler in all the ground floor rooms. We have another air handler that's similar to it, and it's located in one of the eaves up on the third floor and it's carefully hidden away there.
Precisely.
And that will take care of the bedrooms upstairs.
Correct.
Now, in the middle of this thing, we've got just so many different soldered joints. Are they soldered exactly the same as what John's doing here?
No, this is what we call soft solder, and it's a combination of 95.5 solder. But this is silver solder, which is silver brazed, and that requires a much higher temperature, up around 1200 degrees.
That's
This
done in the
requires-
factory
That's done at the factory and all pre-tested.
Okay, so in the middle of the air handler, we've got the squirrel cage fan, and then what's all this down here?
Well, this is the cooling coil, Bob, and this is used in a different season. This will be used, the heating coil will be used in the winter season. This will be used in the summer season.
And basically, that'll circulate Freon.
That circulates Freon through these two pipes that you see right here will be connected to an outdoor condensing unit.
Now, does this unit include an air cleaner or a humidifier?
Well, the unit normally comes with a fiberglass filter, which is located right here, but we're upgrading to an electronic air cleaner, which is going to be right in this area right here.
So that'll be a separate mount on the side.
Yes, it's going to be a 2,000 CFM, that's 2,000 cubic feet of air a minute air cleaner that will remove about 90% of the impurities with every air change.
Okay, Frank, why don't we let John finish up the soldering here, and let's go up to one of the bathrooms and talk about the radiant heat that's being installed in the floor.
Fine.
You know, Frank, one of the worst things about a New England winter is having to walk barefoot onto a ceramic tiled bathroom.
That's correct. Bob, I'd like you to meet Peter Knight from Heatway.
Hi, Bob.
How are you, Peter?
I'm fine, thank you.
So tell us what you're doing here. This is a bathroom floor,
This is a
subfloor.
bathroom floor that we're going to be putting radiant floor heating in the floor in a thin slab. What we're doing now is putting in the heat transfer hose that will be used to carry the warm water from the boiler, circulated through this tube, and then send it back to the boiler to be heated again.
What's this tube made out of?
This is a multi-layered heat transfer hose, and it's designed for applications of radiant heat in the floor.
How hot will the water that goes through here be?
The water temperature that we've calculated for this area will be at 125 degrees.
So this has to be real sturdy stuff.
This is able to handle temperatures much warmer than that. Actually, if you look at it, it has a rating on it up to 180 degrees.
Well, I've got a living room ceiling underneath the bathroom, so I would worry about that.
Right.
Yeah.
You'll just be using the water temperature that you need in order to heat up the slab to the temperature that gives you a comfortable floor.
Yeah, this is the rough part of the job.
Yes.
And then what we'll be doing here prior to ceramic tile installation is to lay down what we call a mud job, which will be kind of a dry mix of Portland cement and sand. And the ceramic tile would be laid on top of that. Now, how do you hook this product, which is either, what is it, vinyl or rubber?
This is a rubber compound that
How do you couple this with the copper piping?
this we use a barb fitting that is fit into the end of the transfer hose.
So you do have
A barb fitting in which that hose fits over it on one end, and then that fitting would be soldered into a regular plumbing copper fitting on the other end.
on the other end right
Correct.
here.
So that would make your connection to the hard piping or copper piping that's normally used to run the hot water from the boiler to a manifold that's located in the area of the radiant heat.
And this, of course, is again controlled by the manager down
Exactly.
at the point of origin. Well, thanks a lot.
Thank you.
It's going to solve the problem.
All right, I hope you'll be
Okay, thanks,
comfortable.
Frank. We've got a break for some messages. Don't go away. When this house was built in 1897, it was illuminated with gas. Probably in the 1920s, they improved the technology up to knob and tube electrical wiring. Since then, I'm sure in the 40s and the 50s, they updated, and as of last year, we had a brand new 200 amp service and then a hodgepodge of different types of wires. We've gotten rid of all of that. Barry Driscoll is totally rewiring the place, along with a few helpers. And I guess this is the feed to the third floor, is it?
Yes, it is. This will feed our third floor sub panel, which also feeds a couple of air handlers, a couple of bedrooms, some bathrooms, and a big entertainment.
That's right. This is basically the third floor teenage area, the living room where you could have parties, you could have a lot of
That's
rock
good.
and roll and a lot of noise. Okay, so that has to go all the way to the basement, right?
Yes, it does.
And it ties into the new service.
Yes.
And then we've got,
Okay, Brennan, feed that up.
okay, we got more similar wire, same size. What size wire is it?
Okay, this is a 3-3 sub feeder, which is going all the way back up from downstairs to this second floor sub panel, just
Okay.
like the third floor, which we
Okay.
just ran.
So if anything goes wrong on the third floor, you go to the sub panel up there to check out the circuit breaker. The same thing happens here.
That's right.
And we're standing in a utility closet on the second floor where we're going to install a stacked washer dryer for immediate family kind of stuff, and we're also going to have storage and kind of linen closet function here. But it serves the purpose of having the panel located accessible but not out in plain sight in the middle of the hallway. Okay, so what are the three? There's a red and a black
The
and a
red
white.
and the black are our hot conductors. The white is our neutral conductor.
The white is the neutral.
And the bare copper is our ground.
And we got to get rid of all the
All the junk.
casings, all the junk, before we can feed it through into the panel.
That's right.
There you go. All right, so this thing goes in through here. You go ahead and get it, Barry.
Bring this right through our Romex connector and up into the panel.
Okay, there's a lot of juice that's coming through here. Now, how do you secure this in the box?
It gets secured actually through the Romex connector, which makes the ground itself to the to the can which the panel is located in.
Okay.
We have our grounding conductor, which is going to go to the ground bar, our neutral, which goes to the neutral bar, and our 2 hot legs come right in on the 2 lugs.
Okay. And then all the individual circuits are labeled here. And you can see, what's that one say?
Stairway hall lights.
Stairway hall lights. Okay, so everything will be identified.
Yes, it will.
But although this, you know, to us looks like we're pulling a lot of wires into place, etc., this is one of the most dangerous jobs that anybody can undertake in a house. And I always discourage do-it-yourselfers from getting involved in this type of work and bringing a professional in. And of course, the professionals have to answer to the inspectors. And right now, we should be able to find a City of Cambridge electrical inspector up on the 3rd floor. All right, let's say hello to Greg Rockland, our project manager and architect.
Hi, Bob. This is Thomas Micheller, Inspector of Wires for the City of Cambridge.
Inspector of Wires, great. Hey, what's this?
This is service light, Bob. So when the serviceman comes to work on this unit, he has some light, doesn't have to...
Now, is that just an added goodie, Thomas, or is that something that's required?
No, that's required by code along with a convenience outlet for servicing the unit.
For servicing the air handler that we were looking at and talking about earlier in the
Yes,
show.
sir.
That's a very, very good idea. Now, I know we've got a sub-panel in here in this storage closet, and I know that you're inspecting just the 3rd floor today, right?
Yes, sir.
Now, what sort of stuff are you looking for when you're doing an inspection?
The sub-panel is one thing that we're looking at, Bob, making sure that we have enough power coming up here and the fact of its location. Now, I did notice you said that this was it's not a closed closet, so that's good because it would be required to not be in here being a closed closet.
I see what you mean. It would be a violation if we had closet rods in here.
Yes,
Now, this was designed primarily almost as a mini trunk room, a place to keep suitcases and the like.
Well, that would be fine.
But do you have to worry about how well tightened everything is and stuff?
Everything has a torque dimension, sir, and it's all on the inside of the panel. You'll notice this being a sub-panel, the ground bar has to be separate from the neutral bar.
Okay.
And they've accomplished that, and they've done a very nice job here.
Now, does the City of Cambridge or the State of Massachusetts allow homeowners to do their own wiring in their own remodeling projects?
Well, no, the state law requires that you be a licensed electrician, and you go to an apprentice course. And
You got to have a license.
Oh, that's most
And in
definite.
fact, as I understand it, Greg, one of the leading causes of house fires and fatalities is electrical wiring problems, right?
That's correct.
Especially in an older wooden frame building, too, you would find that a lot of people have done that themselves, done their own wiring, and it does cause problems.
It is a difficult situation. Now, anything unusual about what we're doing up here you know, we're creating a big kind of family room up here.
Well, basically, everything seems to be in pretty good shape. You've got your outlets, well, by code, required to be 12 feet apart, so that
Okay.
you're not standing at any point more than 6 feet from an outlet.
From an outlet. And that's to reduce the number of extension cords that people use
Right,
and the like.
exactly.
Yeah.
Now, they've done a very good job of securing all their wiring here. And it appears like you're using, I would say, 1/2-inch sheetrock.
Yes.
By the way the box is out away from the stud, about a 1/2 inch.
That's right. And our lighting in here is a little bit unusual.
Yes, what we're doing on the tops of all these beams is strip halogen lighting, which will give you uplight for general lighting. And then if you need to light a specific thing like a pool table or a card table, there'll be track lighting, which you can focus on that.
Exactly. But there's no problem with that, right?
Not at all.
So we pass inspection?
Yes, sir.
Great. Thanks a lot.
All right,
We
thank
got to
you,
break
Bob.
for some messages. Don't go away. And that's going to wrap things up, but it's been a great day. We got that inspection. Come home again next time when we'll be working up on the 3rd floor, putting up the plasterboard and the plaster, putting up some of the carpentry trim, and hopefully out in the front of the house, we're going to be digging a trench for a brand new water service. That's it. Till next time, I'm Bob Vila. It's good to have you home again.